So this time I'm going to deploy an application to Microsoft Azure, and the server application is on GitHub and is open source. I created these applications, and it's a project that I will be talking about on the process while making the deployment. So, and I will mention that this project consists of a server application and a desktop client, and I need to deploy. Okay, let's see this diagram. This is a way to deploy this application that I used, and you can check out the documentation. And in this case, I had an Ubuntu 20 VM running on VirtualBox on top of Windows 10. On the Ubuntu VM, I had to run the desktop client applications to connect to the server applications. So one important fact of this project is that you should use Linux containers or Docker or something similar, but I will be using containers, in this case Linux containers, that are going to run on the Ubuntu VM. And in this case I have one server application that I can run in a different configuration. One of the configurations is as a registry, and the other configuration is as a server. And I will be talking a little bit about the project later, but I will need to say right now that I need to create 2 instances to run on the virtual machine of the server application. So I need 2 containers on top of the virtual machine. I need a container to run the registry application and another container to run the server application. So the objective of this video, let's say, is that I can test the documentation I wrote, because from memory I took all of the commands that are required to perform this deployment, and I have to check whether the commands are right and if I need to add anything else, or I have any other problem that I didn't write in the documentation. So once I check all of the commands and suggestions that I added to the documentation, I will be able to release the first version of the software. And that's the point of this, to verify that the DevOps documentation I wrote is alright, is working, because I wrote all of this by memory and I have to check if everything is alright, and I can eventually release the software. So I will be talking more about it in the process. So I will show you how to use the Microsoft Azure portal, and once you're logged in, let's go to a virtual machine button and create a new VM. I'm going to create a resource group, a new resource group, and by the way I'm doing this spontaneously. I don't have anything prepared, so I'm just recording the video and let's see how it goes. So I'm going to give a name to the virtual machine, name it FS, and choose Ubuntu 20.04, which is the version I'm using right now. Now let's talk about the VM size. There are many VM sizes you can choose. As I recommend the documentation, I recommended to use a V2S or V2MS size for testing this application. That should be enough. So I'm going to choose a V2MS size, which consists of 2 virtual CPUs, 8 GB of memory, and 16 GB of storage. And you have to pay kind of $60 a month. So for testing that will be plenty enough. I'm going to select that size, and that's why you have to take into account for what Microsoft Azure is going to charge on your credit card or your payment method. Username, which username? FS to keep it simple. I'm going to generate a new pair of keys to log into the instance through SSH, and I'm going to leave this by default, but for a production environment you should perform a more detailed configuration. So I think let's click to create and wait for the resource to be created. I'm going to download the private key that was generated, and it can only be downloaded once because it's your private key, obviously. So the VM has been created. Let's go to the resource, and I'm going to connect through SSH. I'm going to access here. So what you have to do is to enter the SSH key, your private key that you just downloaded. In this case, this is the file, and this is how you connect remotely to a server. The name of the server at the IP address where the server is located. So I will enter yes to allow the host name as known, and finally I'm into the virtual machine in which I will be working to deploy the server applications, and I hope everything will be fine. So let's see. You can learn more about the project by reading the documentation and resources that I have created. So this application consists of, as you can see here, a server application that is based on RMI technology. Everything is developed on Java, and I use Java RMI to send remote objects over the network because I'm working in a distributed environment. So I have to send remote objects through the network, and in this case the remote objects are file systems. As you can see here, this file system that is shown on the left panel of the desktop application, it is a virtual file system that is stored on the server container. This application that is going to run on the server container has the physical files. Let me show a bit bigger. this file system that you can see here is physically stored in this server container. That is one of the containers I'm going to set up and deploy right now. And this other container is the registry container. This container is what the desktop application will connect to, and so the physical files stored on the disk are located in this container. The desktop applications connect to the registry container, and the registry container sends the remote object of this server container to the clients, so that each of these clients, an arbitrary number of clients that you can run, will connect to the registry container, but they will be accessing to the server storage, to the server physical file system. So in short, the physical files are in the server container, but you also have to know that each client has a cache of the files. So if this client wants to access a file, you can pull the file from the server, and the file will be stored on the local storage of that client. So you can read and see more about it on the documentation. So now let's go to the steps to make the deployment. So deployment. Once I'm into the virtual machine, I will have to perform some basic maintenance commands. To update the system, apt and this kind of stuff. The next thing that I want to do is to install LXC, which is the technology or the package to create the container. And you can read more about it on the bibliography that I also added to the documentation. You have more information on containers and the commands and tools that I have used for the deployment and from the other resources. So I just installed LXC. Let's see if this works. I'm going to list the containers that I have in this virtual machine. And since I just installed LXC, then I don't have any container at all. So the list is empty, as expected. Then I'm going to run this command to init LXC, and so I will be able to create and launch the container later. I will select the default options. But I'm going to select mm, 8 GB for this size, because I had a problem. Let's see. Okay, select all of the options by default, but I would recommend to give more storage than 5 GB by default to the storage pool, because I had a problem. and that problem was that I ran out of space, and it is also documented here. You can search about it. For example, you can go to the troubleshooting section, and I mentioned that I had storage issues because my container went out of space. So you can see here it is linked to the other article where I explain the error I have, and then I had to resize the storage pool. So once you have run the LXC in it, now we can launch the container. Let's see over here. The command to launch a container is LXC launch, the image name, the version, and the name of the container that you want to create. So in this case, as I have explained before, I have to create a registry container and a file system container. So I'm going to launch my first container for the registry server, and the first one might take more time to create because it has to download the image and install it, but the second one will be much faster. The first container was created, so let's create another container. The second container was created, so let's check the list of containers, and as you can see, I have created the two containers with Ubuntu 20.04 that I'm going to need to deploy the applications, and they are running. So let's see what I have to do now. Next, I have a common setup. That means that I have to perform this configuration and installations on both containers. You have to run these commands on the registry and on the FS container. So to enter to a Linux container, you go like LXC exec. Let's go to the registry container first, bash. Then as you can see, I'm into the registry container. So I'm going to run the commands. And start installing the required tools to run the application. Now, okay, I will install SDKman, which is a tool to install several versions of Java, of tools like Redol and so on, Scala, and many tools that are available to change from one version to another in an easier way. You can read more about SDKman on the bibliography. I'm going to run this command so I don't have to close the terminal, and I can start using SDKman. I will check the installation by running SDK version. So it was successfully installed. So now I will proceed to install Java. Let's see, I'm going to run SDK list Java to check the versions of Java that I have available. In this case, the OpenJDK will be a good fit for this application. In this case, I will install the latest version, which is 16.0.2. SDK install Java 16.0.2 open. Okay. SDK. It is downloaded and installed in Java 16. You should use the latest version of Java if you can, but in this case I'm going to use Java 16 because it's the latest stable version, and Java 17 is coming in September. So let's see the Java version. So Java 16.0.2 is installed in the registry container. Now let's install Gradle. And Gradle 7.2 was installed. So as you can see, I performed the Java installation and the Gradle installation. Okay, I can choose a folder now to clone the repository. I will clone it to the root directory. I can even change the name to a shorter one. Okay, now the project is cloned in the FS folder. And I have the project cloned into the registry container, but I haven't merged the development branch to the main branch because I haven't released the software yet. So I'm going to change the branch that I'm going to use to test the application to the development branch. Hit checkout dev. So as you can see, I'm into the dev branch because the dev branch is what I'm using right now before releasing the software. And I haven't merged the changes to the main branch. So let's exit from the container and enter to the FS container, which is the other container, and execute the same commands. So I finished running the commands on the other container. So I'm going to exit the FS container and go again to the registry container. In the registry container, okay, I haven't tested this pretty well. I hope it will be right, and that's the point of this video. I'm going to install a proxy device. Oh, but I have to run this out of the container. Okay, it's true. In the host VM, I'm going to install a proxy device for the registry container that is going to be called RMI port, and then all of the communication for the TCP protocol and for all of the IPs, and port 1099, which is the default port for RMI, is going to be mapped to the port 1099 of localhost of the registry container. So let's install that device. So it was added to the registry container. So this is the FS container. This is the registry container. IP address. Okay. Let's go into the registry container again, and I'm going to run the application. That's what I'm going to do. Let's see. As you can see, I cloned the project into the FS folder. So I have the project here, and I'm going to go to the server module, and the server module is here. I'm going to make sure that I'm into the dev branch, because as I said, the merge from the dev branch to the main branch has not been done yet, because I'm testing the application. We're in the release, so I have to work on the dev branch right now in this time. So I'm going to run the application. I have to pass the arguments first. Let's see, for the registry container, I have to execute this command to run the application, and I have to pass the registry IP address as the first argument. So the registry IP address is this one, and now I have to pass the type of server that it is going to be, because I have two configurations. This application can either run as a registry server, which is what I'm passing in this argument, or it can also run as a file server application. So in this case, it is going to be a registry server, and so I pass the IP address of the container where the JVM is going to run, that is the IP address of the registry container, and I pass reg to tell the program to run as a registry server. I'm going to open another tab and enter the VM to be able to deploy the other server application. So right now I am running this registry container application, the application running on this registry container, and then in this other tab I'm going to run the server application on the other container. So let's go to it. Let's go and enter into the other container, and I'm going to enter to the project. Make sure I'm into the dev branch, since I am into the main branch. I have to check out to the dev branch. So let's go to the server module and run the server application, the file system server application. So let's see, as you can see, the registry application is running properly. So let's run the file system server application. File system container, which is this one. I have to pass the following arguments to the Java program. The first argument is the IP address of the container where the VM is going to run, that is the IP address of the FS container, which is this one. Remind that I got the IP addresses by running the LXC list command to check the container's information. The second argument is the type of server I want to run. In this case is a file system server, and this time I have to add a third argument to specify the registry IP address, because the file system server, as you can see here, the file system server have to know where the registry server is located. So you have to pass its IP address so that the remote object of the server can be bound into the registry server, because the registry server is what the applications are going to face. It is what the external world knows. The client applications are going to connect to the registry container, and let's say that the server container is going to be encapsulated, and it is not going to be known by the external client application. So I have to specify to the server container the IP address of the registry container to bind the remote object of the server container to the registry, and so that eventually the client applications can access to the remote object of this server application through this registry application. Also, that is the point of deploying a distributed system. They don't have to know this container, only this host machine and the registry container. So let's do that. The IP address of the registry container is this one, and now let's run the server application. The server application is properly running on this container. So that would be it for the server side of the deployment. I hope so.